Hello everyone, my name is Igor and I am welcome you on my YouTube channel. Today I want to tell you about nuclear reaction and ionizing radiation. Uh, let's start. Nuclear reaction is the process in which two nuclear particles interact to produce two or more nuclear particles or gamma rays. Thus, a nuclear reaction must cause a transformation of at least one nuclide to another. The most notable man-controlled nuclear reaction in the fission reaction that occurs in nuclear reactors. Nuclear reactors are devices which initiate and control a nuclear chain reactions. In the picture, we can see the reactor of TPU. Types of nuclear reaction. Also, the number of possible nuclear reactions is enormous. Nuclear reactions can be sorted by types. Most of nuclear reactions are accompanied by gamma emission. Some examples are elastic scattering, inelastic scattering, capture reactions, transfer reactions, fission reactions, fusion reactions, and spallation reactions. Nuclear decay occurs when an unstable atom loses energy by emission ionizing radiation. Radioactivity decay is a random process at the level of single atoms, in that, according to quantum theory, it is impossible to predict when a particular atom will decay. There are many types of radioactivity decay. Alpha radioactivity. Alpha particles consist of two protons and two neutrons bound together into a particle additional to a helium nucleus. Because of its very large mass and its charge, it heavy ionizes materials and has a very short range. Beta radioactivity. Beta particles are high energy, high speed electrons or positrons emitted by certain types of radioactivity nuclei such as potassium-40. The beta particles have greater range of penetration than alpha particles, but still much less than gamma rays. The beta particles emitted are a form of ionizing radiation, also known as beta rays. The production of beta particles is termed beta decay. Gamma radioactivity. Gamma rays are electromagnetic radiation of very high frequency and the therefore high energy protons. There are products produced by the decay of nuclei as the transition from a high energy state to a lower state known as gamma decay. Most of nuclear reactions are accompanied by gamma emission. Neutron emission. Neutron emission is a type of radioactivity decay of nuclei containing excess neutrons, in which a neutron is simply ejected from the nucleus. This type of radiation plays key role in nuclear reactor control because these neutrons are delayed neutrons. Ionizing radiation. Ionizing radiation is any form of radiation that has enough energy to knock electrons out of atom molecules, creating ions. There are many types of ionizing radiation, but the most familiar are alpha, beta, and gamma X-ray radiation. Let's talk about alpha ray. Alpha particles are cluster of two neutrons and two protons each. They are additional to the nuclei of atoms of helium, the second largest and second most common element in the universe, after hydrogen. Compared with other forms of radiation, thought these are very heavy particles, about 7,300 times the mass of an electron as they travel along. These large and heavy particles frequently interact with the electrons of atoms, rapidly losing their energy. They cannot even penetrate a piece of paper or the layer of dead cell at the surface of our skin. But if released within the body form a radioactivity atom inside or near a cell, alpha particles can do great damage as they ionize atoms, disrupting living cells. Radium and plutonium are two examples of alpha emitters. The next beta particles are energetic electrons that are emitted from the nucleus. They are born when a neutron decays to a proton. Since neutrons and neutral particles and protons are positive, conservation of charge requires a negatively charged electrons to be emitted. Some isotopes decay by converting a proton to a neutron, thus emitting a positron. The particles can penetrate matter more than can alpha particles, and it takes a small aluminum plate to stop most beta particles. Radioisotopes that emit beta particles are present in fission products produced in nuclear reactors and nuclear explosions. And gamma rays radiation consists of packets of energy known as photons. Photons have no mass or charge, and they travel in straight lines. The visible light seen by our eyes is also made up of photons, but at lower energies. The energy of a gamma ray is typically greater than 100 kiloelectron volts. X-rays are photons that usually originate from energy transitions of the electrons of an atom. This can be artificially generated by bombarding appropriate atoms with high energy electrons, as in the classic X-ray tube. Because X-rays are produced artificially by a stream of electrons, the rate of output and energy can be controlled by adjusting the energy and amount of the electrons. That's all. Thank you for attention. Like this video, subscribe to the channel. Thank you. Goodbye.